All right, ladies and gentlemen, welcome to 7.4, Sum and Difference Formulas, which are technically identities, and they are on your green paper, so they're going to be a handy thing to have right in front of you right now as we go through this. So let's go ahead and take a look at what these look like. If you have a green sheet in front of you, or if you have a textbook in front of you, you can open up to page 556. There's a little blue box with the sum and difference formulas. And they are actually probably some of the easier ones that we're going to do over the next couple lessons. Basically saying that the sign of a sum ends up being the sine of the first one times the cosine of the second, plus the sine of the second times the cosine of the first. So we can make things work a lot nicer with this sum and difference identity. So you'll notice there for sine, if it's a plus, then it's a plus on the other side. If it's a cosine, then it's the opposite. If you have a cosine of a sum, it becomes the difference on the other side. And you'll get the hang of it as you use it more. All right, so first one, find the first example, find the exact value of the cosine of 75 degrees. Now, if you go to your circle, 75 degrees is not a number on our circle. However, two angles whose sum is 75 degrees are on my circle. And if you go and you take a little bit of time and you search this out, 30 plus 45, you know to be 75. And now I have the cosine of a sum that I can split up using two angles that I know are on my circle. So this becomes the cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. And I'm just going to go do all of this. The cosine of 30 is root 3 over 2. The cosine of 45 is the root 2 over 2. The sine of 30 is 1 over 2. And the sine of 45 is root 2 over 2. And here I get, when I multiply this together as a product, the square root of 6 over 4 minus the square root of 2 over 4, which ends up being, I cannot combine these radicals, by the way. Don't try to do that. All over 4 and done. We now have our answer. That's all we need to do. This is what we call an exact answer because there's no decimal approximation here. So you can't just plug this into your calculator or this whole section would be pointless. All right, let's try another one here. Only this time, let's use radians. Radians are much harder because they're in the fraction form, and people don't like fractions very much. But I'm sure it probably has something to do with a third and a fourth, because those things will make 12. And if you tried it a little bit, you would actually get that this is a subtraction. That pi over 12, this is a good thing to know, by the way, is equal to pi thirds minus pi fourths, which means I can make this pi thirds and I make this pi fourth, and I can subtract those two things, and now I'm going to have the sign of a difference, which means I can go use the difference identity for sine, saying it's the sine of the first one times the cosine of the second one minus the sine of the second one. Oops, wrote it wrong again. Sine pi over 4 times the cosine of the first. And then I go through it, I simplify, I get the right answers here. So sine of pi thirds is root 3 over 2. Cosine of pi fourths is root 2 over 2 times root 2 over 2 times 1/2. Please do not think that the answers always come out as this. Notice we get a root 6 over 4 minus a root 2 over 4. Now you do get a lot of answers where they're pretty close to the same thing. But be careful, they're not always going to come out exactly the same as the other answers. That should be obvious by now as seniors and juniors. All right, so these ones pretty easy, especially if they're numbers. You're basically looking for two numbers on your circle whose sum or difference is 75 or pi over 12. Obviously, the numbers are a lot easier. So you can technically change pi 12ths into degrees and then use the numbers rather than the pi's. What else do I have on this one? What if I wanted to go the other direction? I have the sine of 42 times the cosine of 12 minus the cosine of 42 times the sine of 12. And that looks a lot like my sum identity, or my difference identity for sine. Because I have a sine cosine and a cosine sine, that means it's going to be the sine of, because it's a minus, a difference, and it's just a difference of the two angles here. It's a difference of 42 and 12. Well, that's pretty easy. I get the sine of 42 minus 12 is just, that's just 30. And the sine of 30 is 1/2. So notice you can go backwards. You can start with this big ugly difference and make it into a nice simple difference and make it to a nice simple sine or cosine. Oh, next page. Okay, simplify. Cosine of x minus 3 pi halves. So I have the cosine of a difference, and the cosine of difference looks like this. Cosine x times the cosine of 3 pi halves, because that's what my formula tells me to do. Cosine of the first, cosine of the second, plus, because it's a minus here, the cosine, or sorry, not the cosine, the sine of x times the sine of 3 pi halves. And then I'm going to do this. What is the cosine of 3 pi halves? We know that to be, let's see. Cosine of 3 pi halves goes to a 0. So we get cosine, x times 0 plus sine of 3 pi halves is going to be -1. So I get sine x times -1, and that's 0. And I get just a negative sine of x. Done. Simplified. Right? We know how to simplify things. We just get a new identity to use. Okay, same idea. I thought I'd throw a tangent 1 in here since we haven't dealt with tangent yet. But it's the same thing. I get to use my identities, and the tangent of a sum, obviously tangents, almost every time tangent's a little bit more complicated. It's the tangent of the first plus, because it's a plus here, the tangent of the second, all over 1 minus the tangent of the first times the tangent of the second. Now, some of you are probably wondering, where the heck is 3 pi on your circle? Well, if you go around your circle, here's 1 pi. You go around again, here's 2 pi. You go around again, there's 3 pi. You go around again, there's 4 pi. So we just keep this pattern going. So over here is 3 pi. And the tangent of 3 pi is just 0. So I get tangent of x plus 0 over 1 minus, and you obviously all don't have to write all this stuff, but tangent of x times 0. So I get tangent of x over 1 minus 0. Oh, that's just 1. So it's just, look at that. It's just tangent of x. That's pretty nice. All right, I think I have one more example on this page, and it's kind of a doozy. So I need to solve for x here. And what we're going to do is, because I have the sign of a sum and the sign of a difference, I'm going to use my sum and difference identities to help solve. So I'm going to start with this one, and I'm going to say it's the sine of the first times the cosine of the second plus the sine of the second times the cosine of the first. Then, just to keep us kind of situated here, I'm going to change colors here. Plus the sine of the first times the cosine of the second minus the sine of the second times the cosine of the first, and that still equals -1. Now I need to simplify all the things that I can that are on my circle, like cosine of pi fourths and sine of pi fourths. So this becomes, cosine of pi fourths is √2/2. Sine of pi fourths is also √2/2. And that actually follows all the way along here, √2/2s. Right, so all I've done so far is I've looked at, okay, use my identities, use what I know about my unit circle. And then what I look at here is I look, hey, I have a plus √2/2 cosine and a minus √2/2 cosine, which means those go away. And then I have a √2/2 sine and a √2/2 sine. So if I add those together, I get 2 of them. I get 2 √2/2 sines of x is equal to 1. My 2's cancel. So I get √2 times the sine of x is equal to, sorry, I've dropped my -1. I hope you guys caught that. Then I get to divide by √2. I simplify that to a negative radical 2/2, and I look for those y values on my circle of negative √2/2, which is at, let's see, 5 pi fourths and 7 pi fourths. And there we go. There's our 2 answers for this particular question. All right, hey, look at that. Nice, quick little lesson today, which you probably already figured out since you can see the length of the video. But there you go. No little 2-point question on this one. Maybe people watched it looking for it anyway. All right, so have a good time on this. I will see you guys tomorrow, some of you guys. This will technically be started on Friday, but I thought I'd get it up now. See you guys later.